Hi and Assalamualaikum everyone. Me and my members are going to explain our plant assignment. Modern agriculture, chemical fertilizer are commonly used to increase plant growth. However, excessive use of this fertilizer can damage soil quality, reduce beneficial microorganisms, and cause environmental pollution. Because of this, there is a growing need for more sustainable and environmentally friendly alternative. One of these alternatives is biocompost. Do you guys know what is biocompost? I will tell you. Biocompost is an organic compost made from biodegradable materials such as agricultural waste, food and kitchen waste, and plant residues. These materials are decomposed naturally through biological processes. Unlike chemical fertilizer, biocompost improves soil structure and provides nutrients slowly, which is healthier for plants in the long term. Now, I will explain the three objectives of our project. Firstly, to prepare and apply biocompost made from agriculture and organic waste material for plant cultivation. Secondly, to observe and study the effects of biocompost on plant growth, including height and overall development. Thirdly, to evaluate changes in soil quality after the applications of biocompost.
For this project, the material used are green waste such as vegetable scrap, fruit spills, and fresh kitchen waste. Brown waste such as dry leaves, yogurt as a microbiome starter, trichoderma, water, garden soil, unfertilized soil, and polybags. First, green waste and brown waste were cut into small pieces, then they mixed together. Yogurt and trichoderma were added to help decomposition. The mixture was put into polybags and watered lightly. The polybags were kept in room temperature for 3 weeks. The compost was mixed once a week to ensure even decomposition. For this biocompost experiment, we used 6 polybags. Each polybag has different biocompost ratio. Polybag 1 to polybag 4 contain unfertilized soil mixed with food waste and trichoderma with different ratio. Some polybags also contain microbe from yogurt. While polybag 5 is a negative control which contains soil with fertilizer only. And polybag 6 is a positive control where contains soil without any fertilizer or biocompost. These polybags were used to compare plant growth under the different treatments. Next, spinach seeds were prepared for planting. Spinach seeds were planted in a container. The seedlings were watered together and kept under suitable light condition.
On Monday, ALIYYAH and NURIN monitor plant growth, check soil moisture and water the plant as needed. On Tuesday, SHUWAIBAH and FASIHAH check compost condition, check soil moisture and water the plants evenly. On Wednesday, FASIHAH and AFIQAH observe plant growth, check for signs of stress or disease, and water the plants when necessary. On Thursday, ALIYYAH and NURIN continue monitoring plant condition, ensure adequate sunlight exposure, and water the plants. On Friday, AFIQAH and SHUWAIBAH monitor overall plant health, check for pests of fungal growth, and maintain cleanliness of the planting area. On Saturday, NURIN and FASIHAH observe plant development, monitor compost condition, and water the plants evenly. On Sunday, ALIYYAH and NURIN perform final weekly monitoring, water the plants if required, and ensure the planting area remains calm.
Scheduled monitoring was implemented to systematically observe the growth and condition of amaranth seedlings following their transfer into polybags containing the prepared biocompost. Observations were conducted on a weekly basis to ensure consistent tracking of the seedlings' adaptation to the new growth medium. During monitoring, seedlings were watered either according to feed schedule or when the soil moisture was observed to be low, ensuring the medium remained sustainable for growth. The polybags were placed in a well-lit, warm area to support optimal seedling development. Monitoring also included noting any signs of stress such as wilting or drying, any recording any interactions with insects or other external factors that could affect plant health. This structured approach allowed for organized and reliable observation of plant survival, health and adaptation, providing a clear framework to assess the effectiveness of the biocompost over time.
This table shows the plant growth progress from week 4 until week 10 for 6 polybags. All seedlings were transferred into polybags at week 4, and moisture levels were consistently maintained throughout the experiment. Despite similar moisture conditions, the growth and survival of seedlings were right between polybags. In week 4, seedlings were transferred into all polybags, and moisture was well kept. However, by week 5, seedlings in all 6 polybags did not survive. This suggests that the initial transplant stage caused stress to the seedling, possibly due to root disturbance or adaptation tissue. As a result, new seedlings were transferred into all polybags in week 5, and moisture consistency was continued. From week 6, the newly transferred seedlings began to grow slowly across all polybags, indicating early adaptation. By week 7, differences in growth performance started to appear. Polybag 2, 3 and 4 showed healthy growth, with seedlings growing nicely and reaching heights of approximately 2.5 to 3 cm. In contrast, polybag 1, 5 and 6 show stress symptoms where seedlings began to shrivel despite adequate moisture. During week 8 and 9, polybag 2, 3 and 4 continued to show consistent growth with increasing height indicating better adaptation and survival. However, polybag 1, 5 and 6 experienced further decline where seedlings dried up and eventually did not survive. This suggests that factors other than moisture, such as soil condition, root health, or nutrient availability may have affected plant survival. By week 10, only polybag 2, 3 and 4 had surviving seedlings. However, the number of surviving seedlings was low, with only 1 or 2 seedlings remaining, making them unsuitable for accurate weight measurement. Moisture was still consistently maintained across all polybags. In conclusion, although moisture was consistently maintained in all polybags, seedling survival and growth differed significantly. Polybag 2, 3 and 4 showed better growth performance, while polybag 1, 5 and 6 failed to sustain plant survival. This indicates that moisture alone is not sufficient for healthy plant growth, and other environmental or biological factors may have influenced the results.
For our assignment, we also conducted a survey to find out how much people know about biocompost. We asked questions like, have you heard of biocompost? Do you know its benefits? Have you ever used it? And would you like to learn how to make it? The results showed that most people have heard of biocompost, and a majority of the respondents have actually used it or know how to make it. However, this was only a majority among people that are above 30 years old, while for the respondents below the age of 25 does not know how to make biocompost and never used it before. Then, from the survey conducted, most respondents agreed that biocompost is good for the environment, improves soil fertility, reduces pollution, and supports sustainable agriculture. Most of the respondents also agree that biocompost can help reduce organic waste disposal. Overall, this survey tells us that while awareness is improving, there is still a need for more education, workshops, and guidance to help people, especially the younger generations, to apply biocompost in their daily lives.
In conclusion, this biocompost assignment showed us how easy and useful it is to make compost from organic waste. By keeping it moist, turning it regularly, and using the right material, we produce nutrient-rich compost that help our plants grow strong and healthy. This experiment taught us that biocompost can improve soil naturally and is a practical, eco-friendly solution for sustainable gardening. It's a simple way to care for plants and contribute to a greener environment.